Hi, my name's Sean, and I wanted to kind of walk you through some of the work that my students have been doing with the HoloLens 2. We've posted a bunch of videos that kind of show things in process, but I wanted to bring you in and kind of show you the final result. So they've been working on a program called HoloQuest Space. That is a program that is owned by Crafting Heroes, which is my side business, but they're also high school students that are in my regular classroom. And we have a menu that talks a little bit about the project and explains a little bit about where you can go to get some more information. We have a Meet the Team piece, which we'll have when we're actually showing it to people, but not going to put it up on the list right now for student data privacy reasons. We do have a whole bunch of partners that we had on the project. We had a lot of the assets that we're going to be using in here are Creative Commons or public domain from NASA or from the Smithsonian Institution. But we also have some 3D models that were graciously that we were graciously allowed to use from CreepyCat on the Unity Asset Store. We also have some spacesuit models from Albin, Merle, and a huge shout out to him. And then we have some models from Kitbash 3D. Kitbash actually gave us permission to use some of their stuff in here. We got a little bit of a sponsorship from them, and we also have some enterprise purchases that we made so that we could create the experience. And then the headsets that we're using were actually donated to us by the Navy SSP office. So huge shout outs to all those people, but also just want to make sure that everybody knows that most of the non-spacesuit models, videos, posters, real images are courtesy of NASA, JPL, Caltech, and other NASA branches. And we also have the space shuttle that's in here courtesy of the Smithsonian 3D Digitization office. So quick shout out to our partners. And then there is some information in here about next steps that we're going to be doing. If you're interested in the work that we're doing with kids, you can go and you can check out Crafting Heroes. We also do have a settings menu, and that settings menu gives us the ability to do things like turn on and off particular features like the hand joints, or to turn on and off a debug profiler, or to turn on and off different kinds of hand raise and things like that. So that menu does exist, and it is something that we can use. So we're gonna actually take that and drag it over here real quick, and then go ahead and turn it off. So if in the experience you don't see your hand, we do have a button that will help you to turn your hand on. The entire experience is in here in order to help teach people about space. It's a little jumpy because I'm recording at the same time that I'm kind of walking you through this. But it is typically a little bit less jumpy. So one of the cool things that we have is we have this like circular kind of panel. This was a design that the students had put together based on Cosmos and Neil deGrasse. So, shout out to him. This is us like giving a little bit of homage to that show. And we have buttons on our control panel that we can click. So you can see that over here we have a life-size version with real-time reflection probes. This right here is the Ingenuity helicopter. This is one of the models that is from the NASA, JPL, Caltech websites where you can go to get more resources for like Mars exploration. And we have the ability to take and to like turn on and off the rotors so that you can see the rotors actually spinning, and you can see that the rotors are actually moving in different directions. And if we stayed here long enough, it would actually get to the point where it would go ahead and it would lift off. So I'm going to go ahead and turn those rotors back off, and I'm going to shut this down. Cool thing is that we could go and we could walk around it. The same thing is true for the Perseverance rover. So one of the things that we're not going to have in our typical classrooms is the ability to see the Perseverance rover at scale. But we have the ability with headsets like this and with the kind of programming that my students are doing to bring in these models that were created by NASA and to actually put them out at scale and then to even make them interactive. So in one version of this experience, we have the ability to actually animate different pieces of this. In another version of the experience, we have the ability to explode the view on this so that you can see many of the different components. And if I was to go and I was to get really close to it, you would be able to see that there are really high quality textures on this that give you an idea of what the real thing kind of looks like. So I'm going to come back and I'm going to go ahead and I'm going to turn that off. In the same kind of way, we have different kinds of space shuttles that we can interact with. This space shuttle is actually from the Smithsonian, so I can take this and I can interact with it. But this kind of model right here, while it does give us an idea of what this is like, it's hard to picture this at scale. So one of the things that we did was we went ahead and we made it where we could turn on a landed version of the shuttle with an astronaut model in front of it, so that you could actually get an idea of the scale of how big this is. Again, same model from the Smithsonian. One of the things that is cool about this model, it was scanned at the Smithsonian, and it is it's actually parked in one of their hangars. And so we talked a little bit about that. And one of the questions that the kids had was, well, you know, how big was it when it was standing up? Like, what does that look like? And so we went ahead and we made a version of this where you can actually like look up and you can see just how big it is. Now, in this recording, you're not going to get the idea of the scale of this, but when you actually have the headset on, this is giant, like multiple stories giant, and it gives the kids a different perspective. You know, they're used to seeing things that look kind of like planes in a position like that. They're not used to seeing them stood up, and to get an idea of what it would be like to actually be underneath the launch pad where these booster rockets are. So pretty cool to be able to do things like that. One of the other things that we talked about was we talked about the James Webb Telescope. So we have where you can click and you can see different images, and each one of these images shows a different kind of vision or view of what the James Webb Telescope has been taking pictures of. Cool thing about this is that the kids plan to continue to build onto it so that we can get additional pictures like this as we get those pictures back from the James Webb Telescope. By taking our hand and swiping through these kit bash models, we can actually turn on and off different things. So in this case, you'll see there's a little menu that's down here. If I click on the play button, it'll actually play a video of the unfolding of the James Webb Telescope, and that video that's playing, it does have audio. I don't know if that's going to come through in the video, but we can play back this video. The video was made by NASA, it wasn't made by us, but we can create these kind of interactive video displays. We also have the ability to pause and to stop the video, and each time that we go in and that we press one of these buttons, the students customized the menus based on the mixed reality toolkit so that we could turn these things on and off. Again, we just like swipe our hand through. We can also look though, and we can see the orbit of the James Webb Telescope. And now you can see that we actually have a large sun that's over here. And if we look around, you'll see that we have the Earth and the Moon, and there actually is a version of the James Webb Telescope that's actually in an orbit around the sun that's over there. So again, like not to scale, we went ahead and we put some tags on here so that you knew when things were at scale and when they weren't. When we click on this one though, what's interesting, and it'll take just a second, is that we actually do have a life-size version of the James Webb Telescope right out here. Now it's difficult to see, but one of the students did was they took this like small version of the James Webb Telescope, and they actually made it where you could interact with it, and then we made it where you can see the actual James Webb Telescope at scale. And this model is actually a model that was originally intended for 3D printing, but the idea is here, and as we get in and we do some work on adjusting some of the really high poly models, we will be able to get a little bit better version of this. But this model was actually made available by NASA as well. Cool thing about this one is that, you know, it would be challenging to go out and to actually interact with the James Webb Telescope at scale because of how big it is, but the students made an interesting way for us to be able to grab a much smaller model and actually have that interaction so that you could see a little bit better the scope and scale of the James Webb Telescope. We can go ahead and we can turn that one back off, and if we walk over here, you'll see that this is a pretty high quality model of the Artemis spacesuit, the next generation spacesuit. And so you could come up, and if we get close, you can actually see where stitching is and stuff. And so it makes this kind of model where you would be standing next to the spacesuit something that you could bring into potentially any classroom And that gives you an idea of what the scale is. You can see where some of the connection points are. Huge shout out to Albin and Merle for letting us use these in our experience. We do have a spacesuit room, so when we go ahead and we click on this, it's going to take it a minute to load, and then it will jump us into a spacesuit room. And in that spacesuit room, we have a little bit of a railing in here that kind of shows you where you should be standing. As you come over, if we look, you'll see that I don't have that marker on my hand. So we have one of these buttons in every one of the scenes so that you can turn on the hand tracking. And then we have the ability to click and to see different spacesuits. So this one is not at scale, it's slightly smaller. That one over there actually is at scale. And again, Albin Merle made all of these spacesuits, and when we come up, we can see the stitching. We can see the reflective nature of some of the pieces. And the students have even gone in, and they've actually put on reflection probes so that you can see the reflection of the environment around you on the glass, so that it actually does look like glass. Each one of the spacesuits also has the ability to click and to explode the view into each one of the different components that has been separated in the model. So you could come over and you could inspect the gauges and gears and straps, and you could come over and look at the evolution of the gloves over time, and you could see the boots. It's pretty cool to be able to do that. When you click on the reset button, it'll pull all those pieces back together. And over here, we have the ability to look at early spacesuit suits. We could look at modern spacesuit or postmodern spacesuits. When you go and you click on this, it will go ahead and it'll change out the model. And we can go in and we can look at the Gemini, or we can look at the Apollo. We can go in and we can look at the ACES spacesuit. So if I come down here and I click on this one that says modern spaceflight, you'll see that this right here is the ACES spacesuit, which was worn when the astronauts were going up in the shuttle. And again, when we click on the explode, it'll take it and it'll explode it all out into its pieces with all of the mounting brackets and buckles and all of that stuff. What's also cool about this is that the student took the same thing that we did with the James Webb Telescope video, and they actually made it where we can click on a button here and it will play a video that shows us information about different spacesuits. Each one of these videos is actually set to have a little bit of a picture that shows you which one of the spacesuits you're going to be looking at, and then it actually will go in and it'll play the information about those spacesuits. Shout out to the people who made those videos. We didn't, but we did use them on the inside of our piece. We also have the ability to point at a particular spacesuit and it'll bring up informational panels about them. So if I come over here and I click through, you'll see that we have the, in this case, the EMU. And if we look back down here and we click to one that's a little bit less intensive, you'll see that we have all these spacesuits. We have the same thing. When I take and I look at these, it'll bring up different informational panels. So like if I go to this postmodern one and I go ahead and I jump into like the dragon suit right here and I point at this, you'll see that we do have information in the back that actually is telling us about the spacesuit that we're pointing at. So pretty cool to be able to get in and to see the modern and postmodern spacesuits. Again, just like real quick, going back to the XEMU, which is going to be used on the Artemis missions, we can go in and we can actually click on this exploded view, and you can see all of the different components, including the interior shell that they're using on the inside of the suit. So pretty cool to be able to get in and see a little bit about how this kind of system is going to work. If I reset this and I go ahead and I take my hand, I click back on the hand scanner, it's going to take me back into the main room where I do have the ability to walk around and to see some other things. The students did make a functional telescope, so if you grab this and you move it to the side and you like rotate this around, if you look on the inside of the viewport right here, you'll actually see that there are some pieces that will be reflected or that will be zoomed in on as we move this around. And if you get it in exactly the right places, you can actually find nebulas and other things. Another huge component of this experience was that the students were working on trying to modify Science on a Sphere, which is a projected globe that exists on the inside of lots of different museums and things like that. If we go into the Science on a Sphere room, again, like button in case you need it for your hand joints, we have the button to get us back into the main room. But what the students were working on was they were working on an experience where we could actually turn on different Science on a Sphere planets. And so one of the first ones that we were asked to do by our partner and client on the project, the Space Foundation, was to see if we could figure out a way to help people be able to visualize the rings of Saturn. And there were a couple of different components that they asked us to put into this, including the fact that each one of the rings of Saturn actually moves at a slightly different rate, and that each one was made and is constructed of multiple kinds of things, so rocks and dust and things like that. They asked us to add a component where we could actually get close to this. We could look at a close-up of like, what do the rings actually kind of look like? Again, approximation, not really exactly what it looks like, but it gives that idea that the rings of Saturn are not solid. One of the cool things about this one is that the student who was working on this actually made it so that each one of the rings is actually going at an accurate speed to the rings that are next to them. So if you look, there's these dots that are on there. Each one of those dots is moving at a slightly different rate. You can see the one that's closest to the planet is actually moving faster. That right there is actually the way that it is in real life. And if you point at these, you can actually get it to where you can look and see a little bit about the makeup of the rings. And each one of these has a different set of facts that were identified as being important by the space education specialist over at the Space Foundation, which was pretty cool to get their feedback on this. In addition to that, you'll see that there are some moons and things like that are orbiting. One of the things that would actually happen in the real implementation of this, though, is that there would already be a big globe in the center, and so we have the ability to turn off the projected globe so that you could actually have it have the real globe show up. Now, they asked us to not only do Saturn, but to look at orbital patterns of things like the James Webb Telescope. So if we look over to the side, you'll see that there's the Earth, and you'll see that there is the Hubble telescope actually going around the Earth. You'll see that there's the moon going around the Earth as well, but kind of dim out in the distance, you'll see that there actually is the James Webb Telescope, and the James Webb Telescope is staying on the dark side of the Earth. And over time, what we would like to do is to get probably a little bit more accurate representation of this, but you can see how this would actually be able to be projected on top of the actual globe in the real world. With the sun right here, we have the ability to turn off the sun and to have the orbits of these things actually still stay around where the sun would have been. In the same way, we have Mars on the inside of this, and so we've got the moons of Mars. This is obviously not at the right orbital pattern at the moment, but they are in a ratio of speed that, while it might not be 100% accurate, actually does give you the idea of which one goes faster and which one goes slower. Again, if Science on a Sphere had Mars up there, we would be able to turn this off, and you would be able to see the orbits of the moon around the actual installed Science on a Sphere. So that was our Science on a Sphere mod. We do have the ability to jump back to the main room, and when we jump back into the main room, you've seen NASA models, you've seen Smithsonian models, you've seen different implementations of James Webb information, you've seen that we got spacesuits, that we have Science on a Sphere, we have an interactive telescope that's here. But we also started to make our own game, and that game is called Don't Die on Mars. And we have a couple of different game environments that the students have been working on. So if you click on this one where it says some user assembly required, that's an official NASA poster, by the way. But if you jump in here, this is one of the parts of the project that everybody did. There's actually a constructible rover piece that's in here. That was actually the tutorial from the Mixed Reality Toolkit team. And this one gives you the ability to actually take components of the rovers and to put those together. Like, we can actually snap them into place. Everybody on the project actually made a version of this right here. Cool thing, it has a hints piece, so we can turn on and off hints for where different components go. We have an exploded view piece. The kids actually made a modified version of this to be able to do the same thing with the Ingenuity helicopter and with the Perseverance rover. And And we also have the ability to reset this so that all the pieces go back. One of the things we also did was we modified Kitbash 3D models so that you could come over and you could scan in order to open up something that actually has components and parts in it. We can take those parts and actually come over and assemble the rover. Now, interesting note about this rover, it's not to scale. So the students actually did go out and find what the right scale of this rover was, and then they actually scaled it up on the inside of our rover lab to the correct size. So if I was to go and stand next to that, that actually is the correct size for the rover. They also made it where we could identify a broken part on the rover, so like the generator that's on the back there, and we could actually replace it with a rover piece that would be the fixed version of that piece. So this Rover Garage that was created has Creepy Cat assets to make the background pieces, and then it has Kitbash assets kind of helping to fill it out. Something that's kind of cool is that if you come over and you look outside of the door, you can actually see an environment where we actually do have kind of like a lunar base that's out there. So pretty cool to have like a constructed environment where you could go in and you could interact with some of these pieces. In addition to those pieces, we can click on this in order to jump back into our main room. And when we go back into our main room, there is another part that we have that says surveyors wanted. Again, these are all NASA posters. When you jump into this one, we actually have a drivable rover lab. So if we look outside, it's a little hard to see, but that rover is actually outside. That rover is actually at scale. We can actually take this and we can drive the rover around. So using this slider right here, we can drive it. Because it is a little bit challenging to see the rover, we have it actually projecting what the rover sees on a screen. So we can take and we can grab these pieces and we can actually control where the rover drives, and we can see it here. But if we look out there, we'll actually be able to see the rover doing the driving in that space, which is kind of cool. So pretty neat to be able to have like a drivable rover environment. We also do have the ability to trigger some animations, so we can have it take a sample and we can also have it reset. So when we click on this, it'll actually bring the rover back. It'll bring the rover back, and in this case, because it was on a little bit of a rotation, it didn't set it back in exactly the same place with exactly the same rotational value, but it does take it and it brings it back into the main piece here. Kind of cool that we have, again, like interactive Kitbash elements that you can actually walk around and that you can interact with. So you can pick up some of the bottles, you can look outside, you can see that there's actually a screen that's over on one of these sides that actually has a projection of what the rover is seeing. So lots of interesting things on the inside of this scene as well. And if I take that and I bring us back into the environment, we walk through the little airlock right there. The last kind of part of the exhibit that we have at the moment. So when you come out and you press this button right here, it'll actually take us into a greenhouse that the students made. And that greenhouse has an aquaponics setup. So you can see there's multiple tanks. All those tanks have fish in them. The fish are from an asset package that I purchased for classroom use, and so we have all these fish swimming around. The idea was to kind of visualize what aquaponics would look like, and if we actually come over and we get kind of close over here, you'll see that there are actually plants that are growing. They're growing out of the ground right there, and as they grow over time, you'll actually see that the plants will not only grow on a specific time scale, but they will also eventually get to the point where they flower. So as we look at the plants and the plants, if we just take a second to kind of watch them and stuff, those plants will eventually grow just like they just did, and they'll eventually grow into flowering plants, and then ultimately they'll turn into berry plants and stuff. So you can see the fish, you can see the plants, and when you look over here, there's actually a research paper. This research paper is based on one of the award-winning designs for NASA Deep Space food food production. And so this is actually from a research paper from an organization that won one of the rounds of that competition that NASA has. The organization is actually based out of Golden, Colorado, and it talks about a system that you can use in order to potentially create a habitat that we can grow food on in Mars. There is a citation to it somewhere in the experience, and so very cool stuff. You should totally go and check it out. Student went off and read that documentation and then made something that is not quite as intensive, but is an approximation of what something like that could potentially look like, with the greenhouse, with the exterior windows, with the grow beds, with the plants growing, and with the aquaponic system. So the fish fertilize the water eventually goes through the pipes, it fertilizes the plants, and then through that process, the water is actually returned to the tanks and is cleaned. And so this is a sustainable food system. Kind of a cool thing if we had talked in class about, well, what happens if the fish gets sick. And so if you come over and you put your hand on the hand scanner here, we have to actually go over to this button right here to turn on our hand. But once we have our hand in the environment, when we come over and we click on this, we can actually create a quarantine system. And we didn't watch it actually happen, but you can see that there's like lights that are in here, and there's a little bit of a sound that plays. But also, if you look down here, there is an animation that triggers when you turn the quarantine on and off that would actually shut off the water from the tanks to where you have your plants. So if you look down here, you can see that now we have the flowers on the plants, and if we were to stay long enough, you would actually see that it would grow berries. So anyway, that is the aquaponic part that we've got. So not only have we been working on kind of a little bit more of like a museum sort of setup, where, you know, in the room here, you have these kind of more static experiences that you can touch, you can see them and stuff, or like the spacesuit exhibits where you can kind of see them. But we do have parts of it where it's a little bit more interactive, whether we're talking about exploding the spacesuits, or we're talking about being able to interact with things in Science on a Sphere, or if we have the ability for you to actually step into Don't Die on Mars, right? So all these posters are the official NASA posters. The experience, though, that we were building was actually trying to bring some of these pieces to life. So that's Don't Die on Mars. And we were going to be developing that out over the next couple of years. So if you are interested, we're working on HoloQuest. Space is the first implementation, but we actually have some other implementations that we're also going to be working on in the not-too-distant future. And if you are interested in following our work, you can check out Crafting Heroes. Crafting Heroes is the company that we use to empower kids to, through adventures and through programming, try to learn how to make immersive software like this for actual clients. HoloQuest is our first product. It's Deidre is actually our CEO, and then Sherry and I are working on trying to create opportunities like this. If you're interested in learning more, or you would like to support the work, you can check out craftingheroes.com, or you can check out HoloQuest. We're going to be building that out over the next handful of months. So thank you very much for watching. If you've made it this far, we really appreciate you helping us out and helping out all of our partners on the project, whether you're talking about the Space Foundation, who was our core partner on the project, your local high school like William J. Palmer High School, or if you are interested in supporting any of our other sponsors on the project. I know that everybody would be thankful, and it takes a village to create opportunities where students can step into being empowered to make experiences like this. We look forward to checking in with you again in the future.